There is water floating above your head right now. Not clouds, not rain. Invisible water, hanging in the air around you, all day, every day. And there is a machine that can pull that water out of thin air and turn it into something you can drink. That sounds like something out of a movie, but it's real. It exists. People are buying these machines right now. And the question we need to answer today is simple. Does it actually work the way it sounds like it works? Or is this another piece of tech that sounds better in an ad than it does in your backyard? By the end of this video, you're going to know exactly what these machines can do, what they can't do, and whether one of them makes sense for your home, your land, or your emergency plan. Because the answer isn't a simple yes or no. It's a lot more interesting than that. Let's get into it. So here's the basic idea. The air around us is never completely dry. Even in a desert, there's some water vapor floating around. In a humid place like Florida or Louisiana, there's a lot of it. That water vapor is just waiting to turn into liquid water under the right conditions. You've actually seen this happen your whole life and probably never thought about it. Ever notice how a cold glass of soda gets covered in little water droplets on a hot day? That water isn't coming from inside the glass. It's coming from the air. The glass is cold, the air around it is warm and humid, and when that warm air touches the cold surface, the water vapor in it turns into liquid. That's it. That's basically the whole trick behind an atmospheric water generator. These machines pull air in, cool it down below what's called the dew point, and the water vapor in that air turns into liquid water, just like on the side of your soda can. Then the machine collects that water, filters it, and in most cases runs it through some kind of treatment process before it comes out the tap. In simple terms, most of these machines work a lot like a dehumidifier. If you've ever run a dehumidifier in a damp basement and watched the tank fill up with water, you've basically already seen this technology in action. The difference is that an atmospheric water generator is built and treated so that water is safe enough to drink, at least in theory. Now, some newer systems work a bit differently. Instead of just cooling the air, they use materials that grab onto water vapor, almost like a sponge, even in places where the air is pretty dry. These are called desiccant or sorbent-based systems, and they're a newer approach that scientists are still improving. We'll come back to this later, because it actually matters a lot for one specific type of climate. So right away, we can answer the basic question in the title. Can you really make water from air? Yes. This isn't a scam, and it isn't science fiction. The US Department of Energy recognizes this as a real category of technology. The Environmental Protection Agency has actually studied it directly, testing real machines and measuring real results. This is not some sketchy product with no backing behind it. The physics is solid, and the government has done real research on it. But here's where things get more complicated. And this is the part that most ads and most videos about this topic completely skip over. Just because something works doesn't mean it works well everywhere, for everyone, all the time. And that's the real story here. Let's start with the biggest factor, the one that determines whether one of these machines is genuinely impressive or almost useless in your specific situation. That factor is humidity. Think about it this way. If the air around you is packed with moisture, there's a lot of water vapor for the machine to grab onto and turn into liquid. But if the air is dry, there's barely anything there to collect. It's like trying to squeeze water out of a nearly dry sponge versus a soaking wet one. Same sponge, same technique, completely different result, because the amount of water available is different. This is why the EPA has been very direct about this. Their research says the output of these machines depends heavily on temperature and humidity. Not a little bit, heavily. A machine that produces an impressive amount of water in a humid coastal town might produce a fraction of that in a dry inland climate, even if it's the exact same machine, running the exact same way. And this is where a lot of people get tripped up, including a lot of marketing pages for these products. Most people assume these machines would be perfect for the desert. It makes sense on the surface, right? Dry area, need water, machine that makes water. Should be a perfect match. But it's actually kind of the opposite for most standard machines. A hot, humid place like Florida in the summer is often a better environment for a basic condensation-based atmospheric water generator than a hot, dry place like Arizona. The heat alone doesn't matter as much as how much moisture is actually in that air. Arizona might be warm, but the air can be so dry that there's very little water vapor available to pull out. Florida might be uncomfortable to walk around in during July, but all that muggy, sticky air is loaded with water vapor, which is exactly what these machines need. This is also where those newer sorbent and desiccant-based systems come in. Because scientists know that dry climates are a real limitation for standard condensation machines, there's active research into materials that can pull water out of the air even when humidity is really low. Some experimental materials in lab settings have shown the ability to capture water at humidity levels as low as around 10%, which is extremely dry air. That's genuinely exciting science. But there's an important distinction here. What works in a research lab with specialized materials isn't automatically the same as what you can buy for your home right now. A lot of that technology is still developing, still expensive, or still not available at a consumer level. So if you're picturing a dry desert homestead running entirely on a cheap sorbent machine pulling gallons out of bone-dry air, that's not really where the consumer technology is at yet. Okay, so let's talk numbers, because this is where reality really sets in. Home-scale atmospheric water generators, the kind you'd actually buy and put in your house, have historically produced somewhere in the range of 1 to 20 liters per day. In gallons, that's roughly a quarter gallon up to about 5 gallons a day, depending on the machine and the conditions. Commercial-scale systems, the big industrial ones, can produce thousands of liters a day, but those aren't something you're installing next to your kitchen sink. Now let's compare that to how much water an average American household actually uses. According to the U.S. Geological Survey, the average person in the United States uses around 82 gallons of water per day. And that's per person, not per household. That number includes drinking water, but it also includes showers, running the dishwasher, flushing toilets, doing laundry, and watering the lawn. So picture this. A small home atmospheric water generator might realistically produce somewhere around 5 gallons of water on a good day, in good conditions. That sounds like a decent amount until you put it next to 82 gallons of daily use per person. That machine isn't replacing your water bill. It's not going to fill your bathtub or run your washing machine. What it can realistically do is provide drinking water and maybe some cooking water for 1 or 2 people, especially in an emergency situation. This is probably the single most important thing to understand about this entire technology. Making someone's drinking water and supplying an entire household are 2 completely different jobs. A lot of marketing blurs this line on purpose because off-grid water independence sounds a lot more exciting than supplemental drinking water in decent weather conditions. Now let's talk about something almost nobody brings up when they're excited about this technology: electricity. Cooling air down below its dew point takes energy. These machines run compressors, condensers, and fans, and that adds up. Based on research using commercial units, some machines use somewhere around 1/3 of a kilowatt-hour of electricity for every liter of water they produced. That might not mean much to you as a random number, but here's the practical version of it. If you're picturing an atmospheric water generator as your solution for when the power goes out during a storm, you've got a problem, because the machine itself usually needs to be plugged in and running to work in the first place. This creates a strange irony that's honestly one of the more interesting parts of this whole story. A lot of people are drawn to these machines specifically because they're thinking about emergencies, hurricanes, water main breaks, situations where the tap stops working. But many real-world disasters that knock out your water also knock out your power at the same time. If your atmospheric water generator needs electricity to run, and your electricity is out because of the same storm that knocked out your water supply, that machine isn't going to save you unless you also have a generator or a solid battery backup system to run it. That doesn't mean these machines are useless for emergencies. It just means the emergency plan has to be bigger than just the machine. You need to think about power just as much as you think about the water production itself. Now here's something that might genuinely surprise you, and it's one of the most important safety points in this entire video. Water that comes out of the air is not automatically safe to drink, just because it condensed out of thin air instead of coming from a river or a tap. This is a common assumption, and it's wrong. The EPA has been very clear about this. Atmospheric condensate, meaning the water collected by these machines, is not sterile. Airborne particles, dust, and other contaminants can end up in that water during collection. On top of that, the storage tanks and internal plumbing inside these machines can actually become a breeding ground for bacteria if they're not properly maintained. In fact, the EPA tested one specific commercial machine over a 3-month period. The good news is they didn't detect certain dangerous bacteria like Legionella, but they did find high counts of other bacteria, which suggested there was some bacterial growth happening inside the system, or that the built-in disinfection process wasn't fully doing its job. Their recommendation was that these systems likely need additional treatment, like chlorination, to be reliably safe over time. This is a big deal, because it means the water coming out of one of these machines isn't automatically pure just because it started as invisible vapor in the sky. You still need proper filtration. You still need some form of disinfection. You still need to actually maintain the machine, clean it, and replace filters on schedule. Skip that maintenance, and you could end up with a machine quietly growing bacteria in its storage tank while you assume you're drinking clean, natural, air-purified water. There's also the question of what's actually in the air where you live. If you're in an area with a lot of air pollution, certain compounds floating around in that air could potentially end up dissolved in the water your machine collects. So the idea that this water is automatically cleaner than tap water because it skipped the whole pipe system is really not something you can just assume. So let's talk about cost, because this is where a lot of the appeal either holds up or falls apart. These machines aren't cheap to buy, and they're not free to run once you own them. Based on research, comparing these systems to public water and to bottled water, atmospheric water generators generally end up costing more per gallon than your regular municipal water supply. That makes sense, since municipal water is usually about as cheap as water gets in the developed world. But here's where it gets interesting. When compared to bottled water, especially in a situation where regular water service isn't available, atmospheric water generation can actually come out ahead. So the honest way to think about the cost side of this is that these machines usually don't make financial sense as a replacement for water you're already getting cheaply from the tap, but they can make a lot more sense as a backup option, or as a way to avoid constantly buying and hauling cases of bottled water if you're somewhere without reliable water access. So where does all of this actually leave us? Atmospheric water generators are real. The science is solid. The technology genuinely pulls water out of the air and turns it into something drinkable when it's built and maintained properly. The government has studied it seriously enough to test real machines and publish real data. This isn't a gimmick. But the marketing version of this technology, the one that makes it sound like a magic box that gives you unlimited free water anywhere on Earth, doesn't match reality. Performance depends heavily on your local humidity and temperature. These machines use real electricity, which becomes a serious limitation in a power outage emergency. The water they produce still needs proper treatment and regular maintenance to stay safe. And for most homes, this technology is realistically a source of drinking water, not a replacement for your entire household water system. Where these machines genuinely shine is in specific situations. If you live somewhere humid with unreliable water access. If you want a backup drinking water source for emergencies, paired with a way to power it. If you're trying to reduce how much bottled water you're hauling around. If you're on remote land without a well or municipal hookup, and you want to add another source into your water plan alongside rainwater collection or hauled water. Where they don't make as much sense is if you're picturing complete water independence for an entire family, in a dry climate, without a backup power source, and without a plan for proper filtration and maintenance. So the real answer to, can you really make water from air, isn't yes or no. It's this. Yes, but only under the right conditions, for the right amount of water, with the right maintenance behind it. The physics is real. The limitations are real too. And understanding both sides is what actually lets you decide if this technology belongs anywhere near your own water plan. I put some more resources on this down in the description if you want to dig deeper. Thanks for watching, and I'll see you in the next one.